Good afternoon, Dr. Quinn. Thank you very much for finding the time to speak today. I think hopefully the main thing we can go through is your paper that you wrote as part of the HART Group. And maybe you could
Yeah,
just say a few words, introduce yourself, and I can ask you a few questions about that paper, which I thought was very, very interesting.
yeah. My name is Gerry Quinn, and I have a background in immunology and infection. That's basically it, and I've been working in that field for maybe 15 years now. And I do some articles for the HART Group.
Okay, and I think the one that you wrote specifically that we'll provide a link to is variants and the futility of border closures. I
Yeah.
think the first thing maybe we get into is the idea of variants. You know, how common are variants and what do they sort of mean?
Well, an mRNA virus, it varies quicker than a DNA virus. You get variants occurring all the time. But in this particular instance, then there's a proofreading enzyme that slows down the variation or the variants that occur in this particular virus.
So, well, on that picture, you can see that even with it slowing down, you're ending up with thousands and thousands of variants after the
Oh,
space
just
of a
now.
year or so.
Yeah, definitely. I mean, it's actually the variants are actually going quicker than actually was predicted. There's thousands of variants, and I can't remember how many. There's at least tens of variants of concern just now.
Mm-hmm.
But genetically, or the variation between them is all quite similar. It wasn't really until some governments decided that they would focus in to see how fast the virus was mutating that we started to generate a lot of this data about variants, and the UK being primary and submitting a lot of sequences.
And there's a sort of general theory that over time a virus will get less virulent, but possibly more transmissible. Is there any truth to that?
Truth, yeah.
Or evidence, even better.
Well, just now there's a paper written in 2020 by Dr. King, and he was looking at the previous 4 versions of coronavirus, and he says they were probably instrumental in some kind of pandemics way back in the past. We might be talking about some 100 years ago or more. And they evolved to become more benign. So I think what we're seeing, the case fatality rate, something like for the Delta variant, has gone way down to something like 0.1%.
But I mean, should we always? I mean, the question, I guess, is should we always be worried that there will be this variant coming up? Would it be unusual to have a variant that's significantly worse than the original wild type virus?
Okay, so that's when this particular coronavirus came out, a lot of people seem to throw away the previous history of pandemics, the previous history of immunology and other things. But following trends in the last 100 years, the history of colds and flus is that we do have pandemics, every decadal pandemics, but they usually fizzle out.
So you mentioned the Delta variant, and the case fatality ratio is currently 0.1. That could change, but the Delta variant actually on hospitalization is also much lower than the Alpha variant. Is that correct?
As much, I mean, it's about 1/10, and it's much lower than the South African variant or the Beta variant, and it's also lower than some other variants. Just now, the Delta variant seems to be the latest variant, and the case fatality rate and even the admission rate has gone down. There was a paper recently which went back about 400 years looking at the history of colds and flus, And basically, what the person says is, because we didn't have the diagnostic tools in the past, some of the things that might have been labeled as a flu pandemic might actually have been a cold pandemic. But now, the documentation of these 4 common colds now says they're mostly benign.
So the Delta variant having lower sort of case fatality ratio is in line with history, basically. You'd expect.
It definitely fits with that picture, I mean, obviously, we might want a longer period of time, but from what I see in the trends on case fatality rates, is they seem to be going down all the time. Yeah. Even though they're doing a massive amount of testing just now, looking for many cases, and even some of the symptoms of the coronavirus just now, the Delta variant, it's not immediate hospitalization, intubation on a respirator. It's something like, headache, sneezing. It's not the same as the shortness of breath, or the really severe reactions of some of the first varieties of the coronavirus. That's not to mean that there might not be some case fatalities, but I don't think that picture's playing out amongst a younger age group, and that's who's mostly testing positive just now.
But so in a way, I mean, we are being told quite a lot in the media and by politicians, sort of, watch out, here's the Delta variant. But I mean, what you're saying and what the numbers are saying is it's not as bad as the original first wave.
Well, I've got figures in front of me that says, okay, 0.1 for the Indian variant case fatality rate, and then it says 1.9 for the Alpha variant, which is a Ken, and it says like 1.4 for the South African variant. So that looks like at least a tenth less. So we have to look at what's the latest figures, of hospitalizations, what's the latest figures of death, and they look very low. As some commentators have said, it looks as if the case numbers are now being disconnected from the actual severe illnesses.
Yeah. So I also wanted to ask you a little bit about the something you said about the immunity, that immunity will basically should recognize, because you said, the degree of variation is quite limited. Your immune system should be able to recognize basically all variants at this stage.
Well, at this stage, that seems to be what's happening. The number of mutations per variant is maybe 10 or 11 amino acids. In some cases, I think it's 10 mutations in the South African variant, and yet the spike protein itself is 1,500 amino acids, and there's other parts of the virus, but normal immunity will cut up the whole virus, not just the spike protein, obviously, and display it so that there's a comprehensive immunity to the whole class of coronavirus. What the vaccine does is, obviously, it focuses more on the spike, because that's the part that connects to the ACE receptors on cells, and they think that's the most important part. But that's also a limitation. They could obviously include other parts of the virus to boost it up a bit.
But there are calls now. There was an article in Crick for the Crick Institute that the Delta / Indian variant is a reason to think about going and getting a booster. But I mean.
Yeah, I mean that study from the Crick Institute was very experimental. Let's just say it was an experiment. Mm-hmm. So it was on the hospital population. Mm-hmm. Okay, I was just looking through it. There's 250 people in the sample size. They're all professional and some kind of medical role. There didn't seem to be much of a gradation in the age range, although they said the antibodies seemed to were dropping off in the older age ranges. But it was a very limited study. If you make a model, you want it to be the best approximation to the condition you're trying to test. So they only measured immunoglobulin G and immunoglobulin M, but also immunoglobulin A is very important in something like coronavirus, and also they didn't measure things like memory T cells and B cells, and also innate immunity. I mean, they had to have some kind of test, and the antibody neutralization assay is one of the easiest ways to go. But how far that relates to like the complete response to something like a vaccine is a different, you're looking at a different picture, because there's many arms of immunity that come into play. Something that's really not mentioned a lot is innate immunity, which will sort out the virus as it comes into your body. But also, like I said, the memory response, from maybe a similar coronavirus infection that you caught years ago. There was a paper by, I can't remember. Well, there was a review of previous studies by somebody called Doshi, which found that there was 20 to 50% previous cross immunity to coronavirus diseases, and they were reactive to SARS-CoV-2. So, all of that was left out of the study, okay? And just, it's just a minor point, but in the study, okay, all the participants, they had an average BMI of 24. I've been trying to lose weight recently, so that's why this matters to me, The current average BMI of the UK population is 28. That weight obviously plays a factor in immune responses as well. So I don't think it was completely a representative survey of how people would react to the vaccine. And I don't think that the test was comprehensive enough to account for all the factors in immunity. And that's something that's wrong with many of the so-called modeling studies they do. It's a model. We need answers fast, but maybe they should be a bit more well thought out. So it's just really a snapshot. I mean, I'd quite like more data to come and say, but given the actual data says the case fatality rate from the new variant Delta and from the previous variant is quite low. So if the vaccine, as they say, they didn't just say the Indian variant was 5.8 times less likely to provoke an immune response. They said that also the previous Kent variant and also the South African variant was 5%. And this Indian variant was 5.8. So they decided to choose the figure of the 5.8 for the Indian. They mentioned nothing about the South African variant. Sorry for using these names, but the numbers kind of. And they didn't mention the Kent variant.
Yeah. But so, I mean, but basically, if I'm summarizing maybe correctly, is that the sort of range of variants is quite limited, and you have a very wide immune system response incorporating all kinds of different elements. And so if you take those two things together, from your point of view, we're still not at the point where we have to sort of run out and start getting boosters. So, generally the immune system is able to cope with variants so far based on what we've seen so far.
Well, some of the people that have done these studies have also said there's no need to run out for a booster. The surprising thing was the current booster they're designing is to the South African variant, is not to the Delta variant, the Indian variant. So if they're giving out the booster because they're frightened of the Delta variant, it's actually the template they've got is to the South African variant.
Yeah.
So I'm not sure what logic that was, but I mean, obviously it was time as well. Maybe they were designing it a while back, But what I'm saying is, in some of these calculations, they seem to have forgotten all about immunity. The vaccine works on immunity. It primes the immunity to make an immune response. But there's an immune response for some people before they even get a vaccine because of prior exposure to coronavirus-like particles, or viruses.
And that's the 20 to 50% potentially will have it.
That's just the
from
20
the cold.
to 50% is just maybe previous exposure, memory, T cells and B cells, but also on top of that, there's the people that were infected and didn't know they were infected, or had very, very good immunity, and also developed a new T cell or B cell memory to the new infection. So that must raise the immune profile of the country quite high. So I don't see why there's such a panic. The data says it's very low. The data says it's very low fatality rate, but I'm not sure what interests people are in panic in the population.
Mm-hmm. And then the other one, the other part of your paper, which was really interesting, I thought I'm going to quote it, closing international borders to keep out foreign mutants, which is sort of in inverted commas, of an already endemic virus is neither useful nor possible. Could you sort of, could you expand on that a little bit? Because we're spending so much time focusing on border closures, but your statement there indicates, if it's endemic, what's the point?
Well, I mean, you just have to, look at some of the data on many of the websites. There's many websites giving public data about, so the variant is a series of mutations. These mutations are arising, in Australia, in America, in China, and the UK, independent. The mutations are arising independently, So the virus is already here. And when the virus infects somebody, it produces millions and millions of copies, maybe billions of copies. So every time it does that, it has the chance to mutate, so all those mutations. So obviously it goes for the most advantageous mutation. I think the E484K mutation is found in several of the variants and has been discovered independently all around the world, So it doesn't matter if you close the border tomorrow, I don't think it's even possible to close the border if some person, all it takes is one person, maybe one bird, one cat, one fly, and well, viruses are tiny. There's so many of them around the planet, but it's not. It doesn't make logical sense. The virus mutates. It will continue to mutate. It's already here, and it's mutating independently all around the world. If you close the door tomorrow and think we are done with the variants, that's not true. It will continue to make varieties of the existing virus here,
And
even though we are an island,
Well, I think the other thing you said is the name of the variant means nothing. Basically, it just happens to be where it was first sequenced. So,
well, I think the UK were one of the first ones who were focused on the variants of the virus, but that was just from the nearest person that they could pick up. This person came from South Africa. This person, or it was first discovered in South Africa. But that really that doesn't mean anything. It could have been went from the UK to South Africa first, or the Italian variants could have come from China to Italy, and they're calling them like European variants. So. It doesn't make any sense. They could be originate anywhere and end up anywhere.
So this sort of whole infrastructure we've created, looking at case numbers per 100,000 or 10,000 in different countries, and coming up with green, orange, red, it doesn't mean anything then. If you're saying in each country independently, we're generating our own variants anyway, it's just a natural process. So the flow between countries means more or less nothing then.
Well, I was looking up a figure today. It says there's a quadrillion viruses on Earth, and they're minute. They're like a tenth of a micrometer. So, how could you stop all these floating around in the air? I don't know.
Yeah, and I just wanted to look also how we dealt with this in the past. So I actually pulled up from 2018 the sort of basic assumptions on dealing with pandemics. And back then it was consensus. I mean, it's worth maybe reading as well. Assume no significant epidemiological stroke disease control benefit from international travel restrictions. So what we're doing now is actually not only saying it's illogical from the sense that variants will happen anyway, but it's contrary to what we used to do, and is in the sort of established science before March 2020. Is that right?
Well, kind of. I mean, we need a proportional response. It's not yellow fever. It's not Ebola. You can see a point in which maybe travel to a region that has a hotspot of these diseases might be curtailed. Travel to this region and people coming from that region. But in a pandemic, it's already clusters all over the world. It's out of the country already before you've even identified the people that have it. It's already out of the country. The pandemic means it's all around the world. You can't stop it. But also, a lot of the focus is on the numbers generated from the kind of tests they do, but that doesn't always mean to say that it's from an infectious virus. It could have been, that the higher numbers in some of these tests could be from, a previous infection. They could be from a piece of dust or whatever, So all the testing procedures, maybe exaggerate some of the numbers, especially the way they refer to tests, with coronavirus or of, deaths of coronavirus or with, some of these. I mean, that was an instruction from the WHO, but I don't know if it's helping the understanding of the epidemiology of the virus,
This is the case numbers in different countries then being maybe high.
Yeah, I mean, a lot of countries actually they measure their cases differently, so comparisons can be difficult. Maybe I'm more referring to the way somewhere like the UK or the Ireland measure their case numbers, but these case numbers seem to be now completely disconnected from hospitalizations or case fatality rates. How can you have I don't know what the case numbers are just now.
I don't know either. I mean, hospitalization and deaths are very low, thankfully, but
yeah, but the case numbers are quite they're quite high just now. Although I think they're plateauing, but they seem to be in no relation, to the actual clinical manifestation of the disease.
Yeah, well, we saw that divergence from October 2020, where the case numbers started going up very, very significantly, but relative to hospitalization and deaths, those did not go up anything like those case numbers. So but they diverged quite a while ago. So it's not a useful steering number to steer from.
But in a pandemic or any epidemic, you eventually expect the curve to come down.
Mm-hmm.
I don't think there's any. I'm not sure there's any in history that have kept going plateau. I mean, most of them have a nice bell-shaped curve, or two, but I don't see why it should be completely unique from the rest of immunological history.
Yeah. Good. So let me try and play back to you what I understood and see if I've got this roughly right. Then the variants are a normal process, and sort of general historical experience has been that they get less virulent over time, although that could be a very long time frame. So and
Yes.
The Delta variant seems to be within those parameters, that it's actually less virulent than the first wave version. Is that?
Well, looking at the figures just now, that seems to be the case, and I'm very happy about that.
Yeah, and the travel restrictions more or less will not have an effect at the stage we're at now, where everything's endemic.
Well, I mean,
unless you identify a particular hotspot that should be avoided, but these sort of blanket travel bans or restrictions between whole countries.
Yeah, I'm not. I don't want to comment on it so much because it's become such a political football.
Yeah.
You know, the decisions don't seem to be being made on epidemiology. They seem to be being made on political allegiances. You know, which is not science. You know, so if they were making the decisions on some case data or something, or rational science, then I feel I could comment more, but I don't understand what they're doing just now.
Okay. Well, we can maybe speculate on our website on the political motives, but you can't find a science one. I think that's already quite interesting.
Well, you know, I mean, some of the some of the restrictions are just not logical, and that's what makes me think that there's not much science involved. You know.
Good. All right. Well, thank you very much for that. That's very useful. We'll post this up, and I think the main thing is people should read actually all of the HART Group evidence, which is, I think, an amazing document. I think from memory, there's about 287 external references to underlying papers there. So, you know, and it's written in plain English. The conclusions are very clear, and you can drill down through those references into as much detail as possible. As much detail as you want. So we're going to put the link up on here. I think your paper is very interesting. I'd really encourage anyone that's watching this to link in and look at that paper. It's very clear and very informative, and it's very different to, I think, the impression you'd get by looking at the newspapers, which is, you know, Delta is extremely dangerous, and we mustn't allow any kind of travel.
Yeah. Well, I mean, newspapers aren't peer reviewed, you know. So what can you say?
Yeah. Okay. Very good. Well, thank you very much again, and we'll post this up this evening. Thank you.